Hi, everybody. So, similar to the last lesson, we're going to go through an activity together. But because this activity has a lot of reading in it, I'm actually going to mirror my screen for you versus you guys seeing my face. So, right now, I have the activity up. You're going to see the directions at the top. Say, just follow along with the accompanying video. I'm going to go through it with you. But please, please, please answer the questions in a color other than black. So, if we were in the classroom together, you guys would definitely have me reading out loud with you. We'd be talking through things. So we're going to try to mimic that right now through this video. So I'm going to start reading at the paragraph right here that says, look at the device in this photo. Like the magnetic cannon you investigated in Activity 1, when one ball hits the other, a ball at the other end flies out. This device is called Newton's cradle because it's named after Isaac Newton. Newton was a very important scientist, and learning about him can help you be more knowledgeable about how scientists work to figure things out. You guys, my son just came down with a tattoo. Oh my goodness, Paul, this is amazing. Right now, I'm recording a video. I'm reading out loud to my class, so I have to go back and focus. Your tattoo looks great, okay?
Can I stay down with you?
You can stay, but you have to be very quiet. So when we look at this picture, you guys, this is a Newton's cradle. You see there's a ball to the left and a ball to the right. The big thing I want us noticing with this is that however many balls are moving on one side, the same number of balls is also moving on the other side. So now we're at the paragraph that's called Newton's apple. What would you think of if you saw an apple fall from an apple tree? You probably would not think much about it. Isaac Newton, whom many people consider the greatest scientist ever, thought about it a lot. Newton was a physicist and a mathematician. He lived in England more than 300 years ago, from 1642 to 1727. According to the story, when Newton once saw an apple fall from a tree in his orchard, he suddenly thought that falling was not such an obvious thing. He wondered, why does an apple always fall straight down? Why does it not fall sideways or upwards? These questions led Newton to develop a theory of gravity, which explains that all objects attract each other because of gravity. Gravity makes things fall on Earth. As strange as it may sound, gravity also makes the moon go around the Earth and the planets go around the sun. So we have a picture here. You can see this is Newton, and there's the apple tree. At number 1, I'm putting my cursor on it. We have the apple. 2, you see it falling. 3, it's hitting the ground. So this is what really puzzled him. Newton spent a great deal of time investigating forces in motion. He developed important principles that describe the relationship between motion and forces. You'll learn about these principles in this unit. So right now, if we were in the class, I would ask you some questions like, have you ever noticed that things always fall? Hopefully you have, right? We're 8th graders. We're pretty smart. We know that things always fall from up to down. They always go toward the ground. And what you may have remembered from 7th or 6th grade is I know Mr. Thaler does it. He has a bowling ball, and then he also has a smaller like golf ball, and he goes up high and he drops them, and the teachers on the first floor hate it because it makes the biggest noise ever. But when he drops them, you notice that they both hit the ground at the same time. So you remember that from your 7th grade class, and that has to do with this force of gravity that Newton is talking about, and we're going to explore it a little bit more. So thinking about Newton's cradle, now that you know Newton developed ideas about gravity and force and motion, it probably makes sense that this device was named after him. Newton's cradle is often used to demonstrate some basic principles of energy, forces, and motion. And here's a picture of him. I don't know why they wore these crazy wigs with this crazy hair. I don't know. It's a little nuts to me. So this is a picture of a Newton's cradle. You may have seen it before. You may have never seen this before. They're typically little desk toys that you see in like offices and whatnot. So Newton's cradle usually consists of an odd number of identical steel balls, usually 5 or 7, each hanging from a sturdy frame by 2 strings. The balls are carefully aligned so they are barely touching each other. So here we go to question 1, and this is where I want you to answer the question in a color other than black. So question 1 says, what happens when a ball at one end is pulled aside and then released? What happens when two are pulled to one side and then released? So if you've never experienced this before, you're taking a total guess right now. If this is something that you've seen before, I want you to call back on your experiences. If one ball is pulled out to the left, what happens to the balls to the right of it? Does one ball move? Do all the balls move? What happens when we manipulate this cradle? If you need to take a moment to answer the question on your assignment, feel free to pause me. Go ahead and do that. If you're ready to move on, we're going to keep going by looking at this picture. So in a Newton's cradle, we just said there's typically 5 or 7 balls. So in this picture, this top picture, I have my cursor going around it. We have ball A, B, and C, and then ball D and ball E. And what's happening here is pretend a person pulled 3 balls, balls A, B, and C away from the cradle. When they let go of these 3 balls, when they release them, you'll notice that 3 balls move on the opposite side. It would then be ball C, ball D, and ball E. So you have 3 moving initially, 2 remaining still. Toward the end of it, we have 2 still and 3 that are moving. So the same number of balls that are moved at the beginning of Newton's cradle are also moving at the end of Newton's cradle. And we're going to talk about that in this reading. So when you pull aside a ball at one end of the cradle and then release it, it swings downward until it hits the ball next to it. What happens then is surprising. The ball on the far end of the cradle swings away from the others. All the other balls remain at rest. If you pull 2 aside on the same side and drop them together so they strike each other, 2 balls swing out from the other end. All the other balls, including the 2 you dropped, remain at rest. That sentence right here, I'm going to highlight it, are key. Like, this is so important. All the other balls, including the 2 you dropped, remain at rest. What would you expect to happen if you drop 3 or 4 balls? Regardless of the number of balls you drop, it will always be the same number of balls that swing out to the other side. The others stay at rest. The moving balls stop and hang straight the instant they hit the others. So, I have a link here to a video, and I put big, bold, capitalized. Please mute the volume on this video, as the explanation is much more complicated than I want you knowing at this point. But if you click the link to the video, you're going to see a really cool video that's going to show you this Newton's cradle in action if you've never seen it. So pause my speaking, go ahead and watch that video, and when you're done, you're going to come back to this. We're going to go through question 2. So question 2 says, why do you think that if you drop 2 balls, exactly 2 balls rise on the other side at a similar speed? Why doesn't 1 ball fly off quickly instead? Why don't 3 balls fly off slowly? This is a really difficult question, but try your best to think about what you know and what might make sense. And if you think about the activity that we did a couple days ago with that magnetic cannon, that can help with this. Why do you think the same number of balls at the same speed move through this cradle? Again, right now, there's no wrong answers. I want you to try to think through this, think scientifically. We're going to be inquirers. We're going to think about these questions and try to develop answers in our mind based on what we know and based on the little snippets of force and motion that I'm giving you. You're going to make sure you answer question 1. You're going to make sure you answer question 2. They're both going to be answered in beautiful, complete sentences in a color other than black. You're going to watch that Newton's cradle video, and you guys are going to have an amazing rest of your day. If you have any questions, always please email.